Greetings, one and all, and welcome to this math video. And in this math video, we'll be considering a vector question. Notice what we have before us. It states that the vector OA and the vector OB are position vectors relative to the origin. And what that means is that for this vector OA, because it is a position vector, that means that its tail or its initial point would be at the origin or at the point 0, 0. And the same thing for the vector OB. We know that the vector OB from the question is a position vector. And so that means that its tail or its initial point will be at the origin. So this is the vector OB and this is the vector OA. They are position vectors because they are position vectors relative to the origin, meaning that their initial point or their tails are at the origin. And they tell us that we are given the point 3, -1, and that's A, and we're given the point negative, we're given the point B, whose coordinates is -1 and 2. And so that's what we have here. A is 3, -1. All right, so that's this particular point here, 3 and -1. And B, the point B is -1, 2. And so that's X value of -1 and a Y value of 2. And so they're saying that we give you the points A and we give you the points B. So write the vector OA and write the vector OB as column vectors. Now we have here a pictorial representation of the vectors OA and the vectors OB. But they're saying, no, we don't want a pictorial representation of it. What we want it represented as column vectors. So how would we go about doing that? Let's consider that. So we want to write OA as a column vector and OB as a column vector. In order to do that, what we'll do is notice that we have 3 and -1. And so we have it in a row orientation currently, right? The coordinates are, the orientation of the coordinates is horizontal, right? So we have it looking like this. But what they want is they're saying, no, we don't want it in horizontal orientation. We don't want it like that. We want it vertically like a row, right? So they want us to switch or to change the orientation of how we represent this. And so, let us do that. Let us consider the column representation of this. And so let's do that. So we're going to take 3 and -1, and we're going to not write it in a horizontal form, but we're going to write it in a vertical way. And so that's it right here. So we're going to take this 3 and we're going to put it at the top, right here, like here. And we take this -1 and we place it at the bottom. And so we switch the orientation from being like this to being like this. And that's what it means. That's what it means to write OA as a column vector. That's how we do it. Now the same thing would apply. The same thing would apply for the vector OB. So if we want to write the vector OB as a if we want to write the vector OB as a column vector, what we'll do is we'll take -1, take -1, and place it at the top, and we take -2 and we place it at the bottom. And so this is OB in OB as a column vector. So that's how we do it. So that's OA and that's OB represented as column vectors. Okay, so let us consider the next question. So the next question tells us to express AB, express the vector AB as a column vector. So how would we do that? In fact, how does the vector AB even look? Like, what is its representation? How does the vector AB even look? Let's look at this diagram. Notice that we have the vector OA, right, which starts at the origin and goes to the point A. And we have the vector OB, which starts at O, the origin, and goes to B. And the vector in red is a vector that goes from A and goes directly to B. That particular vector is the vector AB, the one in red. And so they're saying, we want you to write the vector OB as a column vector. And so how would we do that? How would we write this vector as a column vector? So we're gonna start at A and we're trying to get to B. How would we do that? Well, one way to do that is that we can start at A and then go to O. And then from O, we're gonna go from O to B. And so let's do that. So we have the following. We start at A and then we go to O. So that's why we have AO, and that's the vector AO. And then we're gonna move from O to B, and that's why we have OB. Okay, so how how we're gonna continue with this? How are we gonna do this? Well, notice that AO is going in this direction. So let me represent that in blue. AO is going in this direction. That's the direction of AO. But note that note that OA is heading in this direction. Right? So they're heading in opposite directions. So that means that the vector AO is negative OA because they're going in opposite directions. Okay, so AO equals negative OA. And that's why we have the negative here, because they're going in opposite directions. Okay, so let us consider, so AO equals negative OA. So, and here we can see clearly one is going downward and one is going upwards. So that's why we have the negative sign out front, because we're trying to capture the idea of opposites. And to be honest, if we were to actually draw these things, right? So say for example, to really show you and to really help you understand what we mean, if I have AO, right? We know that if I were to say, okay, draw for me the vector OA. Let's draw the vector OA. So if the vector OA would look like this, it'll be OA, right? So that's the vector OA, right? So what if I say, okay, now I want you to draw the vector, I want you to draw the vector AO. So the vector AO, so we're trying to draw the vector AO, right? The vector AO. Now we join the vector AO, how would we do that? It would still be the same magnitude, still be the same size, but we just start at A, and then we're gonna end at O. So it's the same thing. The only thing is that we're just going in opposite direction. So AO is this. We start at A and we end at O. But what if I tell you to draw negative OA? So draw for me negative OA. Well, if you want to draw negative OA, well, what you'll do is that you'll just switch it. So instead of having, you'll just switch the direction. So negative OA, so let's draw negative OA. Negative OA is going to equal to, negative OA is going to equal to, we shift the orientation, it's going to be equal to that. Okay, it's going to be equal to that. And so let me make it a little, let's redraw it. I want to indicate and to show you that they're basically the same thing, just opposite directions. Okay, so that is negative OA. So again, we have O here and A here. So negative OA would be the same OA, but just in a different direction. So what can we say about this? Notice that AO looks the same as negative OA. Look, notice these vectors. Look at this one and look at this one, right? They look identical, right? And so AO equals negative OA, all right? Negative OA. But to be honest, then they don't look exactly identical from the way I draw it, but that's the idea, right? Had I draw them perfectly and had all things been perfectly drawn, then you would really say that they're identical. But hopefully you can see in some sense that these two are exactly the same vectors. Okay, so that's why we say AO equals negative OA, and that's why we have this here. AO is actually equal to negative OA, and that's why we have that there. Okay, that's a better explanation than what I said before. Okay, so let's erase all this. So we know that AB, in order to get from A to B, we can go from A to O, and then from O to B, then from O to B. But what is OB? Remember from what we saw in our previous question, OB is negative 1, 2, and OA is 3 and negative 1. So let's put that inside our solutions. So OA is 3 and negative 1, and OB is negative 1 and 2. And so that's what we have here. And we cannot forget our negative sign. So this negative sign here. So this is actually a negative 1. We can look at this as being a negative 1 up front. And this is saying negative 1 times 3. What is negative 1 times 3? Well, that's negative 3. And then we have negative 1 times negative 1. And negative 1 times negative 1 is positive 1. And then we have negative 1 and 2. We just bring that down here. And we ask, and we say, okay, what is negative 3 plus negative 1? Well, imagine you owe someone $3 and you owe a next person $1. So negative 3 plus negative 1, that means that you owe you owe in total, the total amount that you owe is 4. So that's negative 4. And then we have 1 plus 2. Well, 1 plus 2 is indeed 3. So the vector AB is equal to negative 4 and 3. Negative 4 and 3. Okay, so far we have we have considered A and we've considered B. Now let us look at C, right? C, we want to calculate the magnitude of AB. And this is the symbol for the magnitude of the vector AB. We want to know what is the size of AB, right? How big is the vector AB? So how do we compute the magnitude? So we know that AB is negative 4 and 3, and we're going to consider the magnitude of AB. And the magnitude of this vector, the way how we get it, what we do is we take the top number or the top entry and we square it. And so this is going to be negative 4 squared. Now, what is negative 4 squared? Well, negative 4 squared is equal to negative 4 times negative 4. And negative 4 times negative 4 is 16. Then what we do is we take 3 and we square it. And so that is 3 times, we take the bottom number and we square it. So that means 3 times 3. What is 3 times 3? 3 times 3 is 9. And so that's how we got the 9 here. So here we have 16 plus 9. 16 plus 9 is 25. We have to perform the square root of 25. Now, what is the square root of 25? Well, the square root of 25 is a number that we can use to multiply by itself to give us 25. Now, what number can we use to multiply by itself to give us 25? Remember that 5 times 5, what is 5 times 5? Well, 5 times 5 is 25. So the number that we can use to multiply by itself is 5. So therefore, the square root of 25 is 5. So the magnitude of this vector AB is 5. That brings us to the end of this lesson. We've answered all 3 parts of the question. And so thanks for your time and attention, and I'll see you in another video.